So at first glance of this proof, you guys were working on this, and we're really stuck. Because one of our main strategies that we've used so far is change everything to sine and cos. And we look at this one, and that's already done. Oh, okay. Well, the next strategy after we change it to sine and cos is make both sides a single fraction. That's already done too. So our main strategies are already done for us, and they're not equal. Well, in the last question it said factor. Maybe we can factor something. No, there's nothing we can factor. So every strategy that we have so far does nothing for us in this question. And we are legitimately stuck. And this is the 10% of proofs that when you change to sine and cos and you get it to single fraction, it doesn't work. So we've got to learn a new strategy. And the new strategy is multiplying by 1. Which seems like, well, how is that going to help us? But I call this strategy build the other side. There's fancier names for this strategy. Mathematically, one of the things that we're going to do is multiply by the conjugate. But you don't remember what the word conjugate means in math. So if I use that wording as like, oh, remember that strategy? Yeah, that's the strategy with the word that I don't know, so I don't know the strategy. Then it's not a very good word. I mean, we're going to learn the word again, what a conjugate means in math. But I call it build the other side because those are all English words that you understand, and you're going to see how it works, and it's really quite easy. So if we get to this point where we have both sides as a single fraction, we've changed to sine and cos, and they're not equal, the strategy of build the other side says, well, what could I do to at least make my denominators equal on both sides? So on this side, on the left side, I have sine theta in my denominator. On the right side, I have 1 plus cos theta in my denominator. And so what I want to do is I want to get those denominators the same, and I do that by multiplying by 1. Because if I want a 1 plus cos theta on the bottom of this side, I'm not allowed to just do that to the bottom of this side. But if I also multiply that on the top, then technically I'm multiplying by 1. And I haven't changed what this side is equal to. And if I want the right-hand side to be the same denominator, to have the same denominator, well, I have a 1 plus cos, but I don't have a sine, so I'm going to multiply this side by sine over sine, and I will at least get my denominators the same, and maybe that will help. So on the left-hand side, my denominator is going to be sine theta times 1 plus cos theta. I'm not even going to multiply it out. I'll just leave it factored. Since one of our strategies is factoring, and often when we factor something we can simplify, I'm going to leave it factored. Same thing on this side. I'm going to leave it factored. Not going to risk making a mistake, even though I probably wouldn't make a mistake multiplying it out. But now, when I multiplied those things on the bottom, my denominators are the same. I'm building up the sides so that they're the same. What am I going to have at the top of my fraction? Well, on the right side, that's probably the easier one. Sine times sine. That will give me sine squared. On the left-hand side, 1 plus cos theta and 1 minus cos theta are conjugates. Now, conjugate means it's the same factor with just the different sign in the middle. So I have a 1 and a 1, a cos and a cos. One has a plus, one has a minus. In mathematics, that's called a conjugate. We always have conjugates when we have a difference of squares. Can you see that the top is a factored form? Put brackets around this one too. 1 plus cos, 1 minus cos is a difference of squares. And if you multiplied that out, and you can multiply it all out, 1 times 1 will give you 1. 1 times minus cos will be minus cos, but then you'll have 1 times cos, which will be plus cos. Those go away. And then cos times negative cos will give me 1 minus cos squared. They're still not the same. But now at least my denominators are the same. And so as far as working towards solving this, I now can just say, is there anything I can do in my numerators? Is there anything that you could change? Sine squared is equal to 1 minus cos squared. Because we have sine squared plus cos squared equals 1. Okay? That's on our formula sheet. And anything you can do in your head in one step, you're allowed to substitute. So can you see in one step you could move the cos squared over to the other side and get sine squared by itself and have 1 minus cos squared equal to sine squared. And so when I have that sine squared, I can do that all in one step, write it as 1 minus cos squared over sine theta, 1 plus cos theta. And by building the other side, by getting the denominators the same, we were able to prove this. And it's when we got the denominators the same that our squared identities appeared. Okay? Some ideas of when this building the other side and multiplying the conjugate come up. As you do some of these, you're going to recognize some patterns. Some of the patterns are, if I would cross multiply in this situation, can you see that you would get sine squared equals 1 minus cos squared? You're not allowed to do that on a proof, but looking at it, if you see that situation happening, then multiplying by the conjugate or building the other side is usually going to be a strategy that's going to help you solve it quickly. All right, let's look at part B. 1 over 1 minus cos theta plus 1 over 1 plus cos theta equals 2 cosecant squared. So at first I look at this question, I look at everything. I can't change everything to just one trig function. I can't change it to all cos. I can't change it to all cosecants. So I will change then everything to sine and cos and get my main strategy of get a single fraction. Okay? So I'll do half the work for you. This is not really half the work. You're going to have to do more. But I did the right side. I got the right side to sine and cos in one single fraction. You have to get the left side to a single fraction. How do we add fractions? We need a common denominator. Well, these factors, because there's a plus and a minus, they get grouped together. So when I'm adding fractions and I'm looking at the two, does this fraction at first is missing the 1 plus cos on the bottom. So I'm going to multiply the bottom by 1 plus cos theta and the top times 1 plus cos theta. This second fraction doesn't have a 1 minus cos theta. Even though they're so similar looking, they are different factors. And so this second one, I have to multiply by a 1 minus cos theta and a 1 minus cos theta. And that will give me a common denominator of 1 minus cos theta times 1 plus cos theta. That will be my common denominator. And then on the top, well, I'll have 1 plus cos theta as my first one, plus, because I add the tops, a 1 minus cos theta. So some things to recognize. On the bottom, we have a difference of squares. So if I multiply that out, I will get 1 minus cos squared. On the top, I have some like terms. 1 plus 1 is 2. Cos plus a negative cos will be 0. So the top simplifies nicely to just be 2. So we have succeeded in getting a single fraction on both sides. And now we need to look at this and say, oh, my numerators are the same. Is there a way that I could change either the right side or the left side to be the same? And you can choose either side, because it really doesn't matter. Because if you look at that sine squared plus cos squared equals 1, you could get sine squared by itself equals 1 minus cos squared. I personally probably, like, if I have a choice to change 1 minus cos squared to sine squared, or sine squared to 1 minus cos squared, I like to change this one just so I have to write one less number. It's a little bit shorter. You can finish your test 13 milliseconds before everybody else. Really good, right? And so now my left side is equal to my right side. All done. Perfect. Okay, questions for this one are 12a, but at this point we can summarize everything that we've done. So on page 620 or 634, I would go back to 620. You have an additional workspace, a complete page, all free of stuff. On that page, we can write and summarize all the strategies that we've used so far. Okay? Our number one strategy are those two things combined, right? That's like, if nothing is working for you and you haven't tried changing things to sine and cos and getting a single fraction, then don't come see me for extra help. Because I'm like, if you haven't tried that, you can try that and make mistakes, then yes, I want to see your work. Because in identities, it's through looking at your work that you can find where you're making your fraction mistakes. But you cannot come in identities help with nothing done. Because at least you can change things to sine and cos and use fraction skills to get it as a single fraction. And you might make a mistake in that, great. If it's not working, come see me. But identities, you do need to try something. So I'm going to usually ask you when you're calling for help to see your work, what you've done already. Okay? So those are our main strategies. And then we've added some secondary strategies, right? We've used our Pythagorean identities. If you see a secant squared, a tan squared, a cotangent squared, a cos squared, or sine squared, any one of those squared, in the back of your mind, you should think maybe one of those identities will help me. Because often if you can use a Pythagorean identity, it will make your proof quicker than changing to sine and cos. Now, with that in mind, one of the things we've been modeling as we go along is this fourth bullet. Be aware of what's on the other side. Take a look at the whole thing, because if you think about the whole thing, usually one method may work better than another method. And we've talked about in that one example with cosecant squared and cotangent, that if you say, wait a minute, I can change everything to cotangent because one side has cotangent, the other side has cosecant squared, that's probably going to be helpful. Okay? Now, this one, build the other side and multiply by the conjugate, are sort of the same strategy, except you'll probably forget the word conjugate and then you forget that strategy. But you will remember the words build the other side, so that's why we have it written like that. Because that is going to be a strategy when you get stuck. Okay? I'm going to put this, ooh, we should make it like into a Superman sign. Oh, is that? I can't draw Superman. That was pretty lame. Okay, when you get stuck, this is a strategy you're going to use, and factoring. These are the two strategies that can get you unstuck. Superman strategies, there we go. Sometimes you're going to do the main strategy, change to sine and cos, get a common denominator, get both sides to a single fraction, and 80 to 90% of proofs will be done at the end of that. Sometimes it's just one little easy step to finish them. So you're going to finish a lot of proofs just using our basic strategy. But sometimes you're going to do that, and when you're done, you are going to be stuck. Okay? And you're going to put up your hand and you're going to say, I don't know what to do. And I'm going to say, are you stuck? Yeah, I'm stuck. Well, what were the two strategies? This is to trigger you. Getting stuck is to trigger you to think of these two strategies. When we get stuck, we're going to see if we can factor something. We're going to see if we can build the other side. And in a lot of cases, they're simultaneous. You could use one or the other, and they'll both work. And it's really nice. Right? Some other things, like if you see a +1 on one side of the equation and you don't have a +1 on the other side of the equation, it's probably going to need one of those Pythagorean identities because they all have a 1 in it somewhere along the line. So these are the strategies that we have had so far. We are now ready for all levels of proofs. So on that sheet that I gave you, and we're going to work till the end of class on it, we got up to 20, 24. Now we can enter into the medium level ones from the 20s to 30s, and even get into the higher level ones into the 40s. There's only 2 proofs on there that we haven't developed strategies for. I think they're like question 45 or 47 or something like that. Here, I'll have a look. Okay? No, question 45. So all the other ones you can do. Question 45 requires some advanced math. So if you are done everything else, question 45 is going to be hard because you don't have some advanced math to do it. Question 46 is going to be really hard because it requires you have really good grade 9 skills. And I'm serious, it's going to be hard, even though it requires grade 9 skills. But 46 you can do. But 45, when you're done everything, if you want to see how to do 45, come ask me. All right.